All right. Good evening and yeah, online once again. So we're going to start shortly, and today we're going to discuss the basic syntax of Python mostly, okay, and the underlying ideas. All right. So we will confine ourselves within pure Python. So in the last class, I had shown you quite a few different things about Python, different packages and how they interact and how they can let you do very complicated things with relative ease. And today, instead of jumping into plenty of things all at the same time, I shall discuss the basics of Python, basics of pure Python rather, right? How you actually do conditionals in pure Python, how you run loops in pure Python, what are the fundamental data structures that are available in pure Python, right? And how do you deal with different standard features that are available with pure Python itself. So we're going to discuss the standard features of pure Python itself. We are going to learn the basic syntax, and we are going to learn how Python actually lets you do looping and conditional statements slightly differently than the languages you might be already familiar with. All right. And again, during the session, whenever you have any difficulty, feel free to ask, feel free to raise a question here, and I shall be definitely answering your query, right? All right. As usual, we shall be doing our code in Google Colab, but if you have installed Anaconda, you can just launch Anaconda Jupyter console, Jupyter notebook, and there you can follow along with this code. And after today's class, I shall also send you the handouts, and in this case the handout would be the Google Colab notebook itself, right? And I would show you a few features of Google Colab that I did not show you earlier. And with that said, let us start our discussion today. And again, let's set our expectations right. We are going to learn the basics of Python. This would be something like what you learn out of like first 7 or 8 classes in C programming. So if you learn in C programming, what you learn in first 7 or 8 classes, we shall learn all those things. I mean, all those similar things in this class, right? So this would be slightly fast paced. But again, if you somehow cannot keep up, I would suggest you ask me a question, you interrupt me, and I shall definitely be clearing things up before I actually move forward again. All right. So with that said, let's jump in. All right. So I've already opened Google Colab for you, and just a quick poll. Please let me know if you have in the last week, if you have done something in Python, if you have written a single line of code at least in Python. If you have done that, please let me know, so that actually I have an idea before starting how many of you did anything with Python. If you did do anything with Python in the last week, please let me know. All right. It'll be good to hear if some of you actually did something with whatever we discussed in the last class. In any case, I think the font size is large enough. Maybe I shall make it slightly bigger. All right. All right, so let's start. Our very simple discussion starts with variables, right? So whenever we're talking about programming languages, we inherently talk about variables, right? And variables have a very special name. They are called names, right? So whenever I declare a variable, okay, again, so again, in Python, you don't have to declare the data type first. You don't have to declare a variable. You can just go ahead and assign a variable with a certain value, right? You know that, right? So all the variable names are basically called names. So whenever I write whos and write down and hit enter, I get to see. Okay, so some of you are saying that you actually did something with Python, and so it is very encouraging to know. Okay, all right. So if you write whos and hit enter, shift enter, and execute the code, you will see all the names that are available. So variable names are basically also called names. All right. So with that said, we shall leave those intricate technical details. Okay. So there can be several variables, several different data types. First of all, again, in the last class we did discuss basic variable types. For example, I can have integers, I can have floats. All right. I'm just continuously checking the live chat, so whenever you have any query, so that I can answer as quickly as possible. We can have complex numbers. So these are as far as numbers really go. So say for example 2 plus 3 4j, something like that. We can have complex numbers. Okay, and say 4.5, something like that. Okay, so these are the fundamental data types. So these are kind of the primitive types in the primitive types in Python. So this is the first time I'm running this, so it will take some time to spin up the virtual machine and run everything. All right, so now I have three variables in my repertoire, and one is an integer, the other one is a float, and the other one is a complex number. So if I say whos and then run it, I would see the variables. Okay, so these are the names I have. So the names are x, y, and z. X is an integer, and y is a float, and z is a complex number, right? So their data type is also given, right? So anytime I want to particularly see the type of a type of a variable, so I can say type and I can say x. So if I run that, I will get to see the particular data type of that particular variable, right? So it's an integer, x is an integer. So I think this kind of algebra is fine, right? I mean, there is nothing new about this, right? All right, and again, in the last class I showed you how to actually do mathematical computation, right? You can do all those things. You can do simple algebra very easily, right? So just to show you one more time, say I can do simple mathematics, right? I don't know, maybe something like that, maybe. All right, so I have a result. So this is pretty easy. And again, here if I say double star is power. Here this star is multiplication, this plus is addition. If I say minus, then that's subtraction. This is division. So this is subtraction, this is division. Again, parentheses are taken care of first, and then accordingly, so like that. So this is exponentiation or power, and something like that. So we have raised whatever this is to the power of 2j. It's a complex power, right? So whatever this is the answer. All right, so yeah, these are the very simple basic arithmetic, as to say. All right, so there are a few things I want you to see. First of all, so if I say 1 divided by 0, so the moment I do something like this, okay, it is showing me a Python error. So this is for the first time we are seeing something called an error, right? So in particular, whenever Python compiler encounters an error, it throws something called an exception. So it did cause an exception whenever I divided. Or someone is asking, what is that whos? So whenever I write whos and hit enter, it lists out all the variables that are currently available in my namespace, all the names that are currently available in my namespace. So when I executed this whos, at that point of time in my namespace I only had 3 variables. So whos, the result of this whos command was basically a list of all the variables that I had, or a list of all the names that I had at that point of time in my console. So I basically had 3 variables. One of them was an integer, the other one of them was float, the other one was complex, right? So whenever I write whos and hit enter, so at that particular time, whatever names I have, so names could be variables, names could be Python modules, names could be Python functions, okay, so those will be listed out. We shall see the use of whos gradually again. So I think that is answered, right? So right now the first thing I'm showing you is a Python exception, right? So whenever you do something wrong, okay, something wrong which is invalid, then Python raises something called an exception. Or rather, we say Python throws an exception. Exception is thrown, for example. This is the technical term. So Python here has thrown a zero division error. So it's a zero division exception or zero division error. It says I tried to divide by zero. So it raised an error, or rather an exception. And what kind of exception? It was a zero division exception. It raised a zero division exception, right? So that's understood, right? So now there is a helpful button here. It says search Stack Overflow. So if you ever become a programmer and if you do programming at least as a part-time job or something like that, as a part of your job, then Stack Overflow is going to be your best friend. Okay, anytime you face any difficulty in programming, okay, what do? You search in Stack Overflow. So whenever you search something like, okay, I want to do this kind of thing and this is not working out, okay, so whenever you search, whenever you make similar Google search, the first few results will be from Stack Overflow. So you go to Stack Overflow and figure out what others have done. You just copy paste your code and now magically your code runs. So literally the major part of a programmer's life is looking up results in Stack Overflow. So yes, helpfully Google Colab gives you a link. Whenever you encounter an error, okay, it will provide you a helpful link, okay, to search about that on Stack Overflow, so that you can just click on it and it will take you to Search Overflow. And yes, and if you're an advanced user, then you're going to go to Reddit. But yeah, so if a programmer has 30 tabs open in his web browser, his or her web browser, then it is very likely that 25 of them is going to be Stack Overflow. Okay, right? That's really the thing. And after too many copy pastes, you end up with a code that works, but you don't even understand how it works. That's true mostly. Anyway, so this is called an exception in this scenario, and it raised a zero division exception, right? Zero division error. So that's understood, right? All right. So let's proceed with this. So the first thing I need to tell you are about the built-in data types. Of course, I won't be able to tell you about all the data types that are available in pure Python, but I shall be able to tell you at least talk about at least a few of them, that are actually quite important and used regularly, right? Okay. So in Python, you have certain container data types. So container data types are those data types which can contain many different data types, right? So list is one of them. Python list is one of them. Just hold on a second. All right. So I think this is understood, right? So let's think about the basic data types, right? So again, to make our file helpful, I shall be writing things out, and accordingly I shall write some code with that. Okay, all right. So we're talking about Python lists. The first thing we are going to talk about are Python lists. Again, this was a text block. I added a text block, and then I'm talking about Python lists. Okay. So lists are something like a container data type that can actually contain many different Python data types. And as a matter of fact, a list can contain any other Python data structure. Okay, within, as far as perceivable. All right. So this list is one of the high-level data types. All right. So this list, Python list, can look very similar to arrays in other programming languages, but this is quite versatile than those arrays in other programming languages, right? So let's create a list. So say my list, a very simple list. The name of the variable is now my list, and a list is created with square brackets. So if I say put square brackets, and then whatever I write here will be elements of the list, right? So I can say, for example, I can put numbers. Okay, so let me put numbers. Okay, I can put strings in my list. This is a string. Okay, all right. Strings are basically a set of characters that are coming together, right? I can put another list in my list. So this is another list. So try to understand what I have done. So these overarching square brackets are denoting a list. Okay, and inside that I have created another one, which is another list. Okay, yeah, list is like an array. Only it is far better than an array. An array, in an array, the data types, that the data you could store are of homogeneous types. So basically, if you create an array in C or Java, you only store objects of the same type, right? If you create an array for integers, you only store integers. Okay, you get the point, right? You only store a certain object, right? Certain yeah, data from elements would be coming from the same object type, right? Now here the elements are off from different types here. So in this list I am having an integer, another integer, a float, a string, another array itself, maybe something like I don't know, and this array may contain a character and maybe a complex number, something like that. So this is now an array, and if I want to print this array, I can just say print. Okay, this print function works on any Python object. So if you say print and the name of the Python object, and if I execute this code, of course that list will be created and the list will be printed out. It's a very simple idea, right? So now in Python everything is indexed. So this is how the indexing really works in Python. All right, same, this is the indexing. Rather. So now let's first talk about the indexing in lists. All right. So for lists, right? So here a list would be something like this. I shall enclose everything in square brackets, and I shall have certain elements, right? So in this particular scenario, I had elements like 3, 5, 1.4. So I had 3, I have 5, I have 1.4. Then I had a string, then I had another list, this list is enclosed here, and this is the enclosure. So this was the list we created, right? In Python, indexing is similar to C indexing. Okay, C like indexing. So basically the places at which the elements occur are called the indexes, right? Or indices. So this is the index 0, this is index 1, this element is at index 2, this entire element is at index 3, so this entire string is at index 3, and this entire list is at index 4. All right. So this is how indexing works in lists, Python lists. You get that, right? And out of these, again, if I have elements that can be indexed separately, I can go inside that as well, which we shall learn shortly, right? So now the name of this list was simply my list in this, right? And I can access individual elements by their list indices, right? So this is how list indexing works here. So if I say my list, and within square brackets, if I pass in 0, if I do that, this element will be returned. So if I say my list 0, then the 0th element is returned, right? That's understood. So that actually returns this. If I say that, this actually would returns 3, right? So that will be returned. It's quite understandable, right? Very simple. So similarly, if I say my list, say for example 4, what will it return? It will return, so return means an output of a certain execution, right? So this will return this one. So this is the 4th element. This entire list here is the 4th element. So that will be returned. So if I say my list 4, then this is returned, right? So let's try that ourselves and see how that actually works out. So if I say, for example, and of course, if I want to print them, right? If I say I want to print, for example, my list, and if I want to print the 0th element of my list, and of course, this is the 0th element of my list. So as you can see, this is the 0th element of my list. Understandable, right? Similarly, if I say print the 4th element of my list, again, this is the 0th element, this is the first element, this is the second element, the third, and the fourth, right? Oh, sorry, what have I done? Hold on, I sure. So I did not change the screen. Yeah, see, I have on this list, so what I have done, I have printed my list 0, so it returns 3. All right, so without any issue, right? So if I say print 4, what do I see? Sorry, what did I say? Print my list 4. All right, if I run that, all right, so I now have this 4th element out here, right? So that is extracted without any issue. Right. Now, in this Jupyter Notebook environment, specifically here, this you can avoid this print statement, right? If you just want to print one thing, then you could just avoid these print statements and the result would still be printed. So that's one of the things you need to remember. You don't always have to explicitly say print every time, okay? But I shall tell you when you need to actually say print and something like that. All right, you understand this, right? So there are certain integrated details about Python that I need to I shall be telling you, because as beginner programmers you shall often encounter situations where things might not work out the way you would probably think they should, right? So this is understood, right? Fine. So now somewhat like you need to tell me right now, you need to tell me what happens if I say my list 3 equal to say something like this. If I do that, my list 3 equal to this, so this was my list, all right, this was my list, and if I say my list 3 equal to this, and if I run this, nothing is shown, nothing is printed. But what happened? Can anybody tell me what happened? But what do you think would have happened here, or rather happened here? After doing this, what could happen? So can anybody tell me? Yes, my list 3 was this string, right? My list 3, so this was the third element of my list, and in my list, yes, yes, one of you is right. So the thing is, my list 3 was this element, right? And now what I have done, I have assigned that with a new value. Now if I do print my list, let's see what happened. All right, so can you see what happened? So this was the original string, this was the original string, so this was the original list that I actually created, and here was the element number 3. Now what I have done, someone is saying all the data is overwritten and the variable has become empty. No, the variable cannot become empty here. So look very carefully. All I have done, I have overwritten the third element. So this was the 0th element, first element, second element, third element. So all I have done, I have assigned, so this equal to is an assignment operation, right? So what I have done, I have assigned a new value to the third element, which was this one. So now that element has been replaced with whatever new value I have assigned. Tell me if you understand what I'm saying here. Tell me if you don't understand what I'm saying here. Yes, so it is storing the new data at the particular place we provided, right? So my list 3 was talking about the third element and that has been replaced. Yes, So the third element has been replaced by this, right? All right. So the data types, I mean, this is fine, right? Pretty understandable, right? But this is not always possible with every Python data type. You cannot always replace some part of the data. You cannot always do that. Some data structures available in Python do support that. Some data structures do not. List is one of the data structures that do support modification. So you, after creating a list, you can modify a list, right? So after creating the list originally, we have modified that. So whenever we have an object in Python that can be modified after creation, like that, is called a mutable data type or mutable object. So lists in Python are mutable in nature. So lists are mutable data structures. So lists are mutable. So mutable, of course, the term comes from mutation, right? So you can mutate a list, which means after creation of the list, you can modify things, right? So not every data structure is mutable in Python. We shall soon see data structures that are not mutable in nature, mutable in Python. But list is one of the data structures that are mutable. So after creating a list, you can modify the list in place. No issues, right? Understandable, right? So it's called a mutable data structure, and this is not a Python specific term, right? This mutable and immutable, these terms are used in every programming language. Yes, we are going to look into all the data structures. I mean, as far as practicable today. So don't worry about your question right now. Okay, right? We shall see immutable data structures as well. Data structures that you can create, but then you cannot modify. Okay, once you create it, you have to either delete it or do something like that, or be happy with it. All right, something like that. All right. So again, so I think this is understandable. Let's go back. All right. So with that said, let's. I think this is very much understood, right? Very simple, but it was very simple to understand, right? So with that said, this was assigning a certain value to a list. It's very understandable, right? Is there any confusion? I don't think so, right? So now think about this. Let's go back. Now look at my list. So now my list has become some other value here, right? Let's create another list. Say, let's create another list with a different thing here. Say new list. New list as another variable, right? Let's create that. And here, say this new list contains certain numbers. Say for example 3, 5, minus 20, 0, 7, 6. All right. No issues. Just numbers, right? No problem. Someone is saying no, sir. Can you just tell me what answer you are giving me? Do you have any query? Any question right now? Feel free to ask, because I don't want to proceed unless you understand the things. And Python lists can hold any type of Python object, And Python lists are heterogeneous in nature, so you can mix and match data types inside Python lists. But if you have any query, just be specific in the question so that I can actually figure out what you are talking. Yeah. Okay. Oh, when you said no, I understood it differently, right? All right. So now I said earlier that this was index 0, this was index 1, this was index 2, index 3, index 4, index 5. So very simple. So if I say new list and if I ask for index 2, this will return minus 20. Very simple, right? Very simple. No issues with that, right? All right. Very simple. All right. So with that said, what if I want to extract multiple elements all at the same time? So what if I want to extract something like a sublist from this list? Maybe I want to extract the first 3 elements, all these 3 elements all at the same time, right? So I could do like this. new list 0, then new list 1, something like that. But that would be a very bad way of doing it. So yes, I'm running all the programs, don't worry. Yes, and you shall definitely get homework. I mean, I cannot give you homework right now during the class, because otherwise the class would become like a 3-hour class, right? I don't want that. You won't want that. But I would give you homework, don't worry. And I shall give you the worksheet, entire worksheet. The file will be, the Google Colab file will be shared with you. Okay? Alright, so now if I want to extract these 3 elements, now here comes one of the ideas behind Python that will be kind of might feel foreign to you right now, but later on it would feel quite natural, right? So now if I want to extract the first 3 elements, so if I want to extract the first 3 elements, so let me just do it in code rather. Okay, so let's create a list. So new list, and extract whatever I wrote. 3, 5, minus 20, minus 20, 0, 7, 6. Alright. So if I want to extract the first, so this is the new list, right? Now if I want to extract the first 3 elements, so this is the syntax. Oh, did I say new list? Okay. New list. If I want to extract the first 3 elements, this is the syntax. So look at the syntax very carefully, right? So I am extracting the first 3 elements. So how am I extracting the first 3 elements? I am writing new list :3. :3 would indicate I am extracting the first 3 elements. Let me run that. See, this was my list. The first 3 elements were these 3, and this is like that. No issues, I believe, right? No problem, right? All right, no issues. But I could, please tell me if whenever you have any query regarding whatever I'm writing here, just point me to the line number. So this is line number 17, okay, or rather cell number 17. This was cell number 16. If you are somehow unable to understand a code at a particular cell number, just mention the cell number. I shall explain that once more then. Alright, so you have that. But you can also do something like this. New list 0:3. If I do that, I am getting the first 3 elements returned. Right? I am getting the first 3 elements returned. Got it? Now, let's go back. What I'm saying here. If I want to extract these 3 elements, there are 2 ways in which I can do that. I can either say new list and then say :3. So these extracts the first 3 elements. Alright? And if I say new list 0:3, it indicates, the meaning is extract elements, okay, extract elements starting here and up to this. In Python, the second index is always up to, rather most of the time is up to. Try to understand the terminology here, okay? Yes, I know, I'm pretty aware that if someone is saying that if I'm starting from 0, then of course we do not need to mention that, right? Of course, but I'm showing you the analogy right now here, right? So this indicates that I am starting from the 0th index and going up to the 3rd index, up to. In Python, up to means not including. Up to this, not including. So up to and not including the 3rd element. So if I say give me the elements from index 0 up to index 3, up to and not including index 3. Try to understand. This terminology means give me the elements from index 1 up to but not including index 3. So index 0, index 1, index 2, but not index 3. That is how this is returned. I think this is understood. So these two are equivalent syntaxes here. All right. So this is the starting element from which you are extracting, and the second one is up to. And Python indexing itself is a huge topic. I can give you a lecture, 1 hour lecture on Python indexing itself. Okay, element indexing itself. So there are many fancy ways of indexing, but those won't be required as a beginner programmer. Yes, I do not take any offense. Okay, right? If you know it, then it actually kind of makes me proud. Okay. No. I never take any offense whenever my students actually know something, right? I actually feel sad when you do not know something, right? When you know something, it actually makes me proud. So yes, feel free to interrupt and tell me if you actually know it already. That kind of makes me feel better, really. All right. So that's one of the things. All right. So that's understood pretty much. I think, right? Now, can somebody tell me if I want to extract? What if I want to extract? Let me just copy paste, so that I do not mess things up. All right. Maybe instead of these 3 elements. All right. Maybe I want to extract these 4 elements. All right. What would be the syntax then? So I want to extract from element number 1. Then you tell me. So this is how I'm going to index. Now tell me, please. Yes. I will tell all the indexing properties, all the basic indexing properties. So someone is asking. Okay, one of you is asking, what if I want to extract up to the last element or something like that? I shall talk about that. But someone is saying, what if I want to skip a particular element? Skip a particular element. Or rather, if I want to skip a particular element and keep the rest. Okay, that's an advanced syntax. I shall show you for the sake of answering your question, but I won't be explaining it to you, unfortunately. Yeah, so new list. Of course, understandably, I am starting from index 1. Okay, extract from index 1. So extract from here. And go up to index 5, but do not include index 5. So this would be the Python syntax. So extract from here, go up to index 5, do not include index 5, right? So I believe, most of you have got it correct, right? So if I say new list and start from index 1 and go up to index 5, of course, that would, okay, I cannot type today somehow. All right, so this was my list and I have extracted the first, second, third and fourth elements by writing this. No issues, right? All right, absolutely nice, right? All right, so what if I want to extract up to the last element, right? Unfortunately, you might be at a dilemma right now. What if I want to extract up to the last element? What would your common sense tell me? So what if I want to take this? Now let me take this. What if I want to take this and from a certain point, what if I want to extract up to the last element? Up to the last element. What would your common wisdom tell you? So new list. I want to extract these 3 elements. What would your inner wisdom tell you? I am starting from index number 3. That's fine. Going up to. So last one is going to be up to and not including. Up to and I am going to talk about negative indexing. Don't bring up negative indexing right now. But your answer is incorrect with the negative indexing. So what would your wisdom tell you? That I want to extract these 3 elements Okay, I want to extract these 3 elements, but then what should I put here? Yes, we have to imagine the 6th index. Imagine the 6th index. So if I could write new list 3 colon 6, it would actually work. New list 3 colon 6, it would actually work without any issue. So new list 3 colon 6 gave me the last 3 elements, right? Yes, you did add a last index, right? So understandably, I try to understand that new list 3 colon 6 actually works, right? New list 3 colon 6 actually works, but index 6 does not exist. Index 6 itself does not exist. So if I just say new list index 6, it would be out of bound index error. So index error. So index 6 itself does not exist, but I can extract from element number something up to element number 6, up to and not including element number 6, because element number 6 does not exist, so it did not even look for element number 6. Alright, so that's pretty easy to understand, I believe, right? But there is a better syntax. There is a better syntax, yes. Just like the previous one, if I wanted to start extracting from the beginning, I could have skipped 0, right? So when I wanted to extract something from the beginning, I could have written 0, or I could have skipped the 0. In a very similar fashion, I could have written 3 colon 6, or since I know I am going up to the end, I could have said just this, new list 3 and then colon. That would give me the same result, colon, and we are skipping the last element, means let's go up to wherever we can go. Alright, understandable, right? But just keep in mind that index number 6 does not exist. But before I move forward with indexing, you might have a question right now in your mind. Why on earth am I skipping the last element? Why on earth am I skipping the last element? Is it only to confuse people? So if we add 2 to the last index, yes, it will show you an error. Someone is saying, what if I write 7 here? Then if I write 7 here, what happens? It is going to look for the 6th element, but the 6th element does not exist. That will throw an index error once again. Just to show you, it will throw an index error. Okay, it did not throw you an index error. Wow, the behavior has changed. Okay, fine. It has changed for the better, right? So if you write down something bigger than the final index, you would get up to the final element, right? All right, but you cannot extract elements like that. That is the point, right? But this is the bad syntax whenever you want to extract things up to the last element. Whenever you want to extract things up to the last element, always do that, right? Always do that. Now you might have a confusion right now, might have a question right now. Why on earth would I release the, why would I not consider the last element, right? Why would I not consider the last element? Why am I excluding the last element, right? The point is very simple actually. So if you look at this one, if I write 1 colon 5, what am I doing? I'm extracting from element number 1. So here, look at this one. I'm extracting from element number 1 up to and excluding element number 5. So I'm extracting these 4 elements, right? Yeah, this used to be an error, but this no longer is an error somehow. Okay, so yes, you can write whatever you want at the end, but that won't cause an error. But you cannot just write whatever you want here, right? Because that will be an error. But you can write 10 here, but that will be the same thing up to as the last element, right? Not an issue with that. But what I want you to notice here is that I am excluding the 5th element, right? Understandable. So the last element is always excluded. So, but subtract these 2 numbers. So I am starting from element number 1, going up to element number 5, up to and excluding element number 5. So if you subtract 1 from 5, what do you get? You get 4, right? And incidentally, 4 elements are returned. So this is designed according to what Dijkstra was one of the foremost computer scientists. What Dijkstra actually proposed. Okay, Dijkstra proposed indexing from 0 and indexing with the sense of going up to a point and not including that, because that will help you in figuring out how many elements you are actually extracting from an array or a list. So here, what you are saying here, for example, you are saying give me 3 elements. This number 3 tells you how many elements you have extracted. This also tells you how many elements. So what have I done? Yeah, how many elements have you extracted? It's 3 minus 0. You have extracted 3 elements. How many elements have you extracted here? It's 5 minus 1. So you have extracted 4 elements. How many elements have you extracted here? That's again 6 minus 3. So 3 elements. So that way, whenever you are doing ranged indexing, so these are called ranged indexing. Whenever you are doing ranged indexing, the range, if you subtract the higher range, the lower range from the higher range, you automatically get the number of elements that you actually extracted. That's a huge advantage actually, right? Right? Because that lets you cascade and do cascaded extraction very easily, right? Alright? So this actually makes indexing actually simpler than you might think. Alright. Right. Now, let's imagine I have a very big list, huge list. Okay, maybe with thousands of elements, right? Thousands of elements, right? Now, sometimes what happens, I might want to count from the end. Okay, for maybe I have 10,000, a list, a big list, sufficiently big list. Imagine I have a sufficiently big list, and maybe I want to extract the last 3 elements. The last 3 elements. Then, okay, someone is asking, what if I want to extract particular positions? Python has a particular way of doing indexing like that. Okay, so let me just print once again. Let me just print. So just to answer your question, so Python has a particular way of doing that. So this was my list. Okay, let me just print my list once again, just for the sake of reference. Not my list. Oh, sorry, new list. We're talking about new list. Okay, so this was my new list, right? So within that, now what you can do, you can pass in with new list. What you can do, you can pass in a tuple or something called a tuple. I might have to discuss that later on. I shall discuss that later on. But let me just show you what I mean. What I mean. Oh, somehow W is not working. Hold on. Okay, this kind of indexing is not allowed here. Okay, that kind of indexing will be discussed later on, I think. List indexing must be integers or slices, not tuples. Integers or slices. Hold on, just hold on. Hold on. Okay, what kind of, okay, fine. So regarding your question, someone is saying, the last element. Okay, Mahesh, I shall be answering your question later on, right? Because that kind of indexing is not really, rather not really supported here in native Python lists, but those are supported by NumPy. This kind of list indexing is supported by NumPy. Let me just show you. If I say, let me show you, okay? So if I convert the new list to a NumPy array, so if I say import NumPy, okay, NumPy as np, just let me show you that. Okay, and so np new list. So what I'm doing right now is converting my new list to a NumPy list, np.array. So I'm converting that to a NumPy array. Okay, let me just print np.new list. All right, and I cannot type today somehow. Alright, so what I have done, I have converted my new list to a NumPy array. Again, we shall discuss our all these kind of things in our NumPy classes, right? Now, see, this did not work on new list itself, but if I say np underscore new list, so this is my NumPy new list, and if I pass in something like this, now see that. Okay, let me pass this. Alright, see very carefully what happened. So this is actually supported by NumPy arrays, okay, not by native Python lists. So I just converted my list. So this was my list, right? This was list 3, 5, minus 20, 0, 7, 6. I just converted the same thing to a NumPy array. Okay, a very simple thing. Okay, I have the same list. Now I can do this kind of fancy indexing. I can extract particular locations with this kind of syntax. And there are several other types of syntaxes that Python NumPy arrays actually support, in addition to the things that native Python supports. But whenever you are doing actual programming, whenever you are creating an array, you are highly likely that you are going to use NumPy arrays instead of native Python lists. So this is what so this is to answer your question, right? So if I want to extract position number 0, then that will be true. Then if I want to extract position number 2, that will be true. Sorry, 1, that will be true. Then this is position number 2, this is position number 3, and then these two has to be false. Then I have extracted element number 0, element number 1, and element number 3. Can you see that? But we shall discuss NumPy in a different class entirely, in the next class. So don't worry about that right now. But this is for future reference. Someone is asking, could we do this because the array was so small, but the array is like, yeah. So the thing is, what if I want to extract the last 3 elements, right? Last 3 elements. I give you a long array and I want you to extract the last 3 elements. You cannot just print the array and figure out, okay, I have to start from this element and go up to the end. I cannot do that, right? And someone is asking, can I write true or 1 or 0 in place of true or false? And actually, yes, you can. We shall discuss these things in a different class entirely. You can actually do that. Okay, but unfortunately, what happened here? Okay, this actually did some repetition. We shall discuss all these things in our NumPy classes, right? So let's not. Okay, true is a boolean. True and false are boolean variables. Yes, we could do 0 and 1, then we have to just cast it as boolean. We could do that. I'm just writing true and false. That is how I'm making them true and false. Oh, anyway, so what was my new list? That was my new list, right? So right. So now I want to extract the last 3 elements, right? Extract the last 3 elements. What I could do is that I could calculate the length of the element, length of the list. So this is one function that is available that actually can calculate the length of any Python object if it supports that. If it has a length argument. Then if I say len new list, it tells me that there are 6 elements in the new list, right? So of course, if I want to extract the last 3 elements, I could do something like this. I could do new list. Try to understand. I could do new list, and then I could calculate len new list. Okay, and I could do len new list minus 3 and then colon. Do you understand what I'm doing here? I'm extracting the last 3 elements. I could use this kind of a syntax. So essentially what I'm doing 3 colon. Essentially, because len new list, this will return 6. I have subtracted 3 from that, and I'm writing colon, so it will go till the end of the list. So that way it will give me the last 3 elements. That way it will give me the last 3 elements, and this is the only syntax that you can use in C, C++, and Java. But Python has a better way of doing it. Okay, Python So you understand this term, right? So you just calculated the length of the list, subtracted 3 from that, and started from that index and went up to the end. End of story, right? But there is a better syntax in Python, right? Python allows you to count from the end. So let me just again go here. Python allows you to count from the end. So for example, if I say, so these are the indices that are there when we are counting from the beginning. But then at the same time we can count from the end with something called negative indexing. Okay, so this element, whenever we are counting from the end, is element number -1. This element is element number -2. This is -3, -4, -5, -6. This provides you with a handy way of counting from the end. So you can count an array from the end. So if you want to extract the last 3 elements, you can simply say new list, extract from index number -3 till the end. So you are extracting from index number -3. What is the index number -3? So index number -3 is the third element from the end. So index number -3 is the third element from the end, and we are extracting till the end. All right. So a better way of this would be simply new list -3 colon. That would extract from the start extracting from the third element from the end and go up to the end of the array. All right, end of the list. Sorry. Very simple to understand, I guess. All right. I hope this was understood. All right. And again, you can, if you are feeling fancy, then you can say something like, if I say new list, -5 colon -3. Yeah, you can do stupid things like that. So -5 colon -3. So that would give you these 2 elements. You could do that, right? You could do that. But this kind of things are not recommended really. But yes, if you are counting from the end, you can do that. So this will extract from the 5th element from the end and go up to, but not including the 3rd element from the end. Yes, colon is a very different syntax. I would skip that. Yeah, so somehow there is one more question. If I say -3, so someone says -3 colon -1. If I say -3 colon -1, okay, so if I say -3 colon -1, then again the problem is that this is excluded, right? This is excluded. So these 2 will be extracted. So if you are using negative indexing and if you want to go to the end, you really have no other option than to skip the last index. Because if you write -1, that indicates that we are going to skip the last element. You get my point, right? You are going to skip the last element, right? So you cannot just add 1 with that, right? Because that will end up with being 0, and 0 is a positive index, means the first one. So that is also going to be wrong, right? So if you are using negative indexing, there is one gotcha that if you want to go till the end of the array, you have to skip the last element, which is again the recommended way nonetheless. So that's not an issue, I think. So you get the point, right? All right. Yeah, -3 colon -1. So if I say something like this, okay, again, I am not jumping into complicated indexing things. We are going to do those complicated indexing while actually studying NumPy, because those are more relevant there. I mean, you hardly ever do this kind of indexing in pure Python, rather. All right. So there is one more important thing, a very important thing that I want you to see. For example, let's create a list. Very simple. Say X. I'm renaming my variable X. Let's give it some values. Say A, B, some elements, I don't know, one, whatever, some values. Alright, I'm happy with this. Now X is the list. Now X is a very simple list. Let me just print X. X is a very simple list, right? Pretty understandable, right? Right? So if I say Y equal to X, what happens? Okay, Y equal to X, what happens? Y is also a list. I think you understand now. X was a list. I assigned the value of X to Y, and Y is also a list. If I print that, okay, that is also printed, right? No problem, no issue, right? Right? So Y is also a list. Now if I say Y0 equal to, so if I say this, what happens? The 0th element of Y is now changed, right? Now look very carefully. I created a list X. Then I wrote Y equal to X. So Y was another list, okay, that had the same value as in X. And now I'm writing Y0 equal to something. So I have reassigned the 0th element in Y, right? So if I print Y, of course, the 0th element of the list Y has now changed. Of course, that has been reassigned to this. Ha 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 ha, right? Evil laugh. Right? Question. Would anything have happened to original list X, to this original list that I actually originally created? Would anything have happened to that because of my shenanigans here? So I created a list X. I wrote Y equal to X. So I assigned a new variable Y, and where I assigned X, the same list, back to that, and I changed the first element of Y, right? So would anything have changed in the list X? What do you think? If I say just right now, if I just print X, if I am going to print X here, if I print X here, am I going to see something different? Someone is saying I have copied the list X into Y, so no change will happen, right? What else? That is the popular wisdom, right? Nothing will happen, right? Let's see. Let's print X. Okay, I just printed X. What happened? I just printed X. What happened? What happened? It changed. Wow. What happened? Really? So I created a list X. I assigned it to Y, then changed something in Y, but that change now also appears in X. What happened? This happens because of this. Something like this. So you create a list. Okay. In Python, again, this is very specific to Python. Okay, right? Of course, I'm asking you because I'm not asking you because nothing was, not because nothing was going to happen, right? I asked you because something was going to happen, right? In Python, lists are by default copied by reference. It's called copied by reference, copy by reference. So what I mean is that if I create a list X with some value, say 2, 5, who knows, 0, whatever, right? And I say Y equal to X, then the data that is containing in X is not copied over back to Y. It is not copied. Only whenever I do something like this, this happens. Whenever I create something like this in Python's data storage, this is created. So X is a name. Again, I told you variables are nothing but names. So whenever I said x equal to this, what happened? X was the name, and this name was referring to this list stored in Python. No question of inheritance whatsoever. Okay, so yes, we have a point of reverse reprinting, and in Python we have plenty of methods, I'm telling you. But then whenever I'm doing this, y equal to x, what is happening? The data is no longer copied, only a new name is created, and the name is referring to the same thing, right? Okay, right? So it is like calling the same person with two different names. So this is a person, imagine this is a person, I'm just calling it with two different names. This is nothing, this has got nothing to do with inheritance or whatsoever, those object oriented things. This has got nothing to do with that. This is just referring to the same thing in memory. So x and y are referring to the same thing in memory. So if you change one of them, the other one will change as well, right? So in Python, by default, these kind of objects are copied by reference, not copied by just copying a duplication. Not copied by duplication, but copied by reference. Okay, got it? I'm going to show you list methods, don't worry. Done. So this was one of the important things, and I should tell you. And if you really want to copy, my question now, of course, your question would be, what if I want to copy a list? You might want to do that, right? So if you want to copy a list, then you would do something like this. You would import copy. So copy is a module. You would import copy, and from that, now x was this, imagine x was this. So wait, hold on, let's create the same original list. Let's say x was this, right? All right, let's have that. All right, and say if I want to copy it, then I'll say copy dot copy. Okay. Yes, your question would be, of course, obvious question is, how do I copy, right? So that changing one of them does not change the other. So this is the syntax. So you would import the copy library, and from that you would call the function copy. This is something called a shallow copy. Okay, so you've created a copy now, but it's a shallow copy. Okay, shallow copy. So I shall explain this briefly. So now just say x is this and y is this, right? But if I say y 0 equal to, say the same thing, of course y has changed, right? So I have assigned a I have changed the 0th element in y. But did anything happen to x? No, nothing has happened to x anymore, because x is now something called a shallow copy. This is called a shallow copy. Okay. Now you might ask, what is shallow copy? Of course, shallow is the antonym of deep, right? So it's a shallow copy. Now, shallow copies are fine as long as my list does not contain another list. If my list contains another list or another complicated Python object, then what I need to use is a deep copy. To explain this, let me change this a bit so that it actually contains another list inside. Let me show you. Now, try to understand, x is a list that contains another list inside. Okay. Now if I run this, and of course x is this, now y, now try to understand, now y is a shallow copy of x. Shallow copy means that it will copy all the superficial elements, but if there are nested elements, this is a nested element of course here, then those won't be copied, those will be copied by reference. So what happened here? So let me just show you then again. Then y was this, then if I change the first element in y, of course y would have changed, but nothing would have happened to x, right? Try to understand. I have changed the 0th element in y, it has changed, but nothing has happened to x. Okay, we are still happy because we did not touch this part. But if I somehow touch this part, okay, do some modification inside this, but then that modification will also reflect back in here. So if I say y and say which one is which element is this? This is 0, 1, 2. This is index number 3. So if I change index number 3 and some element from index number 3, so index number 3 itself is a list. So if I want to change this, so index number 3 is this entire list, and out of that this is index number 1 because this is index number 0 of this insider list, right? So this is the syntax I had shown you earlier. Okay, so this is now talking about this element in y, right? And if I say this to be something like that, okay, of course I have changed y, right? With that I would have changed y. Okay, right? So this element has been changed, but since this was a nested element inside the original list, but I only did a shallow copy, now x would also have been changed. See, this element in x did not change because this was copied, but this was only referred back. So this is a shallow copy. So if you want a complete copy of everything, use deep copy. So if you the recommendation, so if you want to copy a list or copy any Python object, I would always recommend a deep copy. Okay, so this is, so always do a deep copy if you want to copy a Python list. Okay, that's always recommended because you might have side effects like that of shallow copy, right? So I would say y equal to copy dot deep copy then x. So that would create a deep copy. So every nested element will be copied. So in the entire memory block will be copied. So changing one of them will not in any way change the other. So I think we have cleared up. All right. All right. I think that's understood, right? Any confusion up to this? So if I have any doubt, let me know. So I started this discussion imagining that I would be telling you about default Python constructs like if and those if statements and loops like that. But probably we will end our discussion with data structures, right? So there are plenty of other data structures that you need to know first. All right. So now let's talk about Python dictionaries. All right. So let's talk about dicts or dictionaries, right? Python dictionaries. So dictionaries do have other names. If you are coming from Java, dictionary would be familiar to you in the name of hash table, right? Someone is saying, can I explain 63 and 64? Yes. So what happened here is that previously whenever I copied this was a shallow copy. Shallow copy means that this would be a copy as far as there are superficial elements. So in the copy that y created, what happened? This was copied, this was copied, this was copied, but this was referred and this was copied. So in y, if I make any change into an element that was copied from x, then that change will not reflect back in x, right? So I changed this element in y. Okay, so that element changed in y, but that change did not reflect back in x. But since this was a shallow copy, which means any nested element will be referred instead of being copied, so this was referred. So this was not a copy. this was referred, this part was referred. So this was partly copied, partly referred. So if I do make any change like that inside this, so now inside this what I did, so this was my y here, and in y this was the element. So this was 0th element, first element, second element, third element, and out of this third element itself is a list, and this is the first element of the third element. So first element of the third element, sorry, first element of the third element of y. So I have changed that. So of course that change actually reflects in y because I have changed the first element from the third element, right? So I have changed this into boo ha ha ha, right? So basically evil laugh, right? I have changed into that. And now what happened, since this part was actually shallow copy, this part was actually referred from x, this was not copied from x because this was not a superficial element, right? A top level element, if you want to say, think about that way, right? So this did not go deeper into this, so only a reference of this was copied. Because of that I made this change here in y, but that change actually came to be also there in x, because this part was not copied, this part was referenced, right? So whenever I say copy, what happens is that nested elements are referenced, okay, or rather referred, okay, but superficial elements are copied. So I always recommend a deep copy if you want to copy a list. Now if you want to ask you, okay, but why, what was the point of creating a copy by reference? Okay, the point of creating copy by reference was just to save memory, right? Often what happens, we want to copy things without actually copying all the elements and something like that. And not only that, I think I need to discuss one more thing. Not only that, say x was this, right? Let me create a few code blocks. X was this, right? If I say another list and z is now, say for example, colon 3, z is now colon 3, okay, z is now colon 3. Of course, what is z then? I have assigned a new array, new list, and this is now colon 3. What is colon 3? Of course, the first 3 elements from x. So these 3. Keep in mind, this is also a reference. This is not a copy at all. Same thing happens here as well. This is also a reference to the original list. This was original list x. This, whenever I'm assigning something like this, this is a reference back to the original list as well. So, of course, understandably, the same thing will happen if I make any changes to z. Maybe I want to change the first element from z. Okay, so okay, so instead of saying Python, I am saying snake. Although the name Python has not got anything to do with the reptile. If I do that, of course z would have changed, understandably. But since z was basically a view into x, it was a reference, so x would also have changed. But I'm telling you this thing because no one taught me when I was a student, and I encountered many complicated issues back in those days, right? Many different issues, complicated issues back in those days. Now, what happened here? Right? Right? Okay, so this is the other way around. So if you make a view, this is again copied. So a good way of copying things would be making a view out of a list. Okay. So you can always do trial and error. But again, whenever you want to copy something, always make sure to do a deep copy, just to be absolutely sure that you are not messing things up, right? But again, these are all intricate details on about the programming language. And again, as engineers, we do not really need pure Python as much as we need other Python libraries, really. Okay. Any more question like that? All right. So again, if you have any query, otherwise we shall go back to this. So let's talk about Python dictionaries. Okay, again, Python dictionaries are also mutable data types. These are also mutable. Python dictionaries are mutable data types. Okay, before I can discuss Python dictionaries, let's postpone that for a while. Let's talk about strings. These are strings are immutable. Okay, got it. Strings are immutable, right? So let's talk about strings. Instead of dictionaries, let's talk about strings right now. First. Okay. Strings can be defined in okay, just one more thing. If I say whose right now, see, I have copy, but was copy a variable? So x, y, z, these are variables, of course. Was copy a variable? No, copy was a name. And what kind of name was it? It's a module, right? I have my list, new list, these are lists. NumPy was also a module. NP new list was NumPy ND array, n-dimensional array, and things like that. All right, so let's forget that. Okay, right. So let's create a new variable. So strings can be defined with delimiting characters like this. So if you within quotes, within single quotes, if you write something, then this is a string. Okay. Then you can create another string with double quotes. This is another string. Okay. Right. Then you can mix and match like this. See, so inside this string I have included an apostrophe, right? So since I am including an apostrophe here, okay, I cannot use this syntax for writing a string. I have to use double quotes like that, because these double quotes will be delimiting the string, and otherwise what would happen is if I write this here, the string will be enclosed like that. Somebody is asking, in Google Colab we do not need to write print to print always. Sometimes we can just okay. Those who are having issues with PyCharm, I will explain that later on. But right now, what you have essentially here is something called the IPython console, and modernly it's called Jupyter console. In Jupyter console is something called a REPL, read, execute, print loop. Okay, or rather read, evaluate, print loop. Here, it's called REPL, right? Terminology is REPL. It's called. So what you are seeing, this cell. So whenever I am executing the code, these cells are technically called a REPL. REPL. Read, evaluate, print loop. Loop means keep doing it. So whenever in a cell in Google Colab or Jupyter Notebook, whenever in a cell I write something and then execute it, then it reads, it evaluates the cell, it prints, and it loops back. That is what is happening. So this print is there inside the REPL. That is why you get print for free in Colab, right? You don't get that in PyCharm. Okay. Okay. All right. So I think I answered your question. So if you are doing it in PyCharm, you have to write print everywhere. And again, if you are developing Python programs, it is always recommended that you write print statements whenever you want to print something. Okay, right? So this is an interactive environment. Here, I mean, not writing print is not an offense. But whenever you are developing a Python program, if you want to print something, you have to write print. Otherwise, things won't be printed. And you shall see shortly that it is not always the case that something is printed. Not always something is printed. We might have to write print deliberately to print something here. All right, so I'm just showing you different ways of assigning strings, right? So if you want to delimit, have a single quote inside, then you have to enclose your string with double quotes, right? So say I'm writing a conversation between some person, right? Say I'm creating a new variable p, who knows? Okay, then I'm writing a conversation, okay, something like that. Say then he said, I don't want to want to study anymore. Maybe. Okay. I want this entire thing to be a string. But now see, I have double quotes, so I cannot use double quote to enclose this string, because if I do that, Python interpreter might have a problem. See what happens. Python interpreter thinks that this is a part of the string. This Python does not know what to do with it, and then Python is completely confused right about here, right? Since since inside the string I have single quote and double quote, then I cannot use single quote and double quote to delimit the string. So instead I have to use another Python syntax, is that there is triple quote. So this is also a string. So this is the string, and the triple quotes are delimiting the string. Now if I enclose a string with triple quotes, then I am allowed to put single quotes and double quotes wherever I want. So if you're writing conversations, then of course you would have double quotes and single quotes inside whatever you are writing. So these double quotes are now part of the string. Here this single quote is part of the string, but here this single quote is not part of the string, but it is indicating that whatever is inside this is a string. Here this double quote is not part of the string, but these double quotes are indicating that whatever is inside the double quotes are is the string. Here this single quote is part of the string. Here similarly these double quotes and this single quote are part of the string. So let me just print all of these. Print x comma y comma, sorry, let me just print everything individually, otherwise things won't be printed actually. Right? So see, this was printed first, then in this one again, then again this was the part of the string, and again, as you can see, there is just one more thing. This this triple quote in Python could be triple, actually this triple quote could be triple double quote as well, the same thing. What am I doing? You can say triple double quote as well. So yeah, this is the string. Now you can delimit things with triple double quotes as well. So if I run this, the same result will happen here. Okay, I just did something wrong here, I think. Hold on. Okay, yeah. Yeah, I just needed to put a space here, because otherwise it was thinking like I had 4 quotes, right? So yes, so perceivably this is better, right? Alright, so you have plenty of options to choose from. Right? Alright. With that said, strings do support indexing as well. Okay. So say this. Say I'm saying this is a string. For example, this is a string. Say, let's talk about the first string here. So I'm saying this is a string. Then I would have T H I S, then space, then I S, then space, then space, right? All right. So let me just divide everything. All right. So yes, you understand. So this was the string, right? So we are talking about this string, this particular string here, right? So here, this is again index number 0, index number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And same kind of indexing properties do happen here as well. So if I want to extract this substring out of this, then I would say, so this was x, right? This was x. So then I would simply say x1 colon 7. 1 colon 7 would extract this part of the substring. So the same kind of substring, the same kind of indexing actually happens in strings as well, right? Same kind of indexing that you actually studied in lists, with a noticeable difference, we shall see. So if I say 1 colon 7 here, 1 colon 7, right? So of course that part of the string is extracted. So it was his, is, something like that. So again, I'm not repeating myself here, so you can understand that everything that you studied are again applicable here. But I said strings are immutable. In contrast, that lists were mutable. What I mean by that is that, say for example, if I say x0, x0 was the 0th element in x. What was 0th element in x? That was t, right? Now if I say x0 equal to something, if I want to assign a new character at place x0, so x0 was the first element in the string x. So if I want to assign a new character here, it will throw an error saying it's a type error. So it says string object does not support item assignment, simply because string objects are immutable objects in Python. You cannot mutate them, you cannot modify them in place. Space is counted, yes. Space indeed is a character. Space itself is a character. Here someone is saying, is the space not counted? Yes, space is a character. This is the 4th character here is a space, the 7th one is a space, 9th one is a space. Alright. Right. Just one more thing. Length is also applicable on strings. So if I say length x, it shows me how many characters there are in x, including spaces, of course, including spaces. All right. So that actually is one of the things that you need to remember. All right. All right. If you have any query, feel free to ask right now. All right. Then. All right. So let's talk about dictionaries. Python dictionaries. These are also known as hash tables in other languages. But I think dictionary is the, easy to understand term here. Question: what is a dictionary? What is a dictionary? A dictionary is basically a list of words and then associated with a list of words associated with a meaning, right? So in a dictionary you would have certain words, and those words are known as keywords, right? Whenever you want to search for something in a dictionary, you look for the particular keyword in the dictionary, right? So you would have a keyword, and associated with that you would have a value, which is basically the meaning here, right? So you would have a word, and then associated with that you would have a meaning, right? Similarly, you would have another keyword and you would have a value, another keyword and a value, and so on. So dictionary in Python is kind of this thing. Okay, this is also called hash table. Now this is kind of a what should I say, even a higher data structure than list. Okay, so if somebody asks you what is the highest level data structure that you have built in Python, that would be dictionary. Okay, Python dictionary is the highest level data structure in Python. Python dictionary is the highest level data structure that is available within Python. This is the highest level data structure. So let me show you how this actually really works. All right. So let's put a text here. All right, Python dictionaries. All right, let's say, right, let's create a dictionary. Okay, say X. Very poor name, but let's say X. Okay, the syntax is curly braces. So within curly braces, you create dictionary. All right. So curly braces, and of course there would be keyword and the values, right? So say India is a keyword, and then kul is a value. Okay, so I'm saying India. Say I'm stating the capital. Okay, okay. I don't know. Okay, right. Right, just say simple things here. What should I say? Okay, our neighboring country, right? All right. So we have created a dictionary containing keywords that refer to countries, and then values that refer to the capital. Some people might beg to differ with me. Yes, right. So now I have a dictionary. I might want to print the dictionary. So if I say print X or just X, doesn't matter. So now X is the dictionary, right? So it has that. Now dictionaries are again indexable, but not indexable in a way that lists were indexable. So lists had integer indexing. See carefully. So list indexes were integers. So 0, 1, 2, 3, 4. These were the indices in lists, right? So here again negative integer indices. Now dictionaries on the other hand allow arbitrary indexing. What do I mean by that? Here in dictionary you cannot do this. You cannot extract the 0th element of a dictionary because there is no 0th element in the dictionary. This will be an index error or rather key error. Okay, it says that there is no 0th element in the dictionary, but so dictionaries are not indexable like this. Okay, but dictionaries are indexable this way. So X was this. If I now say X, and then if I pass in the keyword, what do I see? Now try to understand. So this is now allowing you arbitrary indexing. So dictionary is like a list in steroids. Okay, so this dictionary is the list that allows arbitrary indexing. Okay, you can imagine a list to be a dictionary that has integer keys, right? So if these were all like integer keys like 1, 2, 3 and so on, so 0, 1, 2, 3 and subsequently like that, then you can consider a dictionary to be a list. Okay. So if I say X India, then I have New Delhi, right? X USA. Okay. So now I can index by keys. So previously for lists we were indexing by their index values. Now we are indexing with keys. So you can consider lists to be special kind of dictionaries where the indices, where the keys are basically integers starting from 0, right? Something like that. And again, so as you can see, something like that. But again, since I'm telling you that dictionaries are the highest level Python data structure available built in within Python, dictionaries can contain anything. Dictionaries can contain any Python object, and the objects could be heterogeneous in nature as well. Okay, let me show you what I mean. Okay, only but there is a problem with keys. Let me show you. Okay, say I'm creating another dictionary. Okay, another dictionary. I'm putting heterogeneous objects. Look very carefully. So I'm saying A. So the first key in this dictionary is a character. Okay, and say assigned with it is a number, integer. So this kind of assignment is valid. The second key is a number, and the corresponding value is a string, right? Then say I have another string and corresponding corresponding value, I don't know, something like this, maybe, I don't know, who says. So now I have heterogeneous assignments here. Look very carefully. For this key value pair, the key is a string and the value is an integer. For this key value pair, the key is an integer, the value is a string, and for this pair, both of them are strings. So I can happily assign them and happily deal with them, right? So I can say y, and then if I want to extract say 1 2 3, something like that, then corresponding to this I have the result, right? That's understandable, right? This is again being treated as integer, right? So no issues with that. Only problem is that the keys used in dictionaries should be immutable objects. So keys used in dictionaries should be immutable objects. Integers, numbers like that are immutable objects, right? Numbers like that are immutable objects. But see what happens if I want to say something like this. I want to create a dictionary where the key is mutable. Say, for example, an example of a mutable object is a list. Say, okay, so this is the key and this is the value. This is the key value pair, simple. But see what happens. Python now shows an error. This is the only restriction that is there in dictionaries, that keys should only contain immutable objects, right? So numbers, strings are fine, but you cannot assign a list as the key in a Python dictionary. Okay, right? It says unhashable type. Okay, so unhashable type means it's a mutable object. So just clearing the terminology, immutable is also known as a hashable type. Immutables are also called as hashable. And mutables are called unhashable. Mutables are called unhashable. So this has got something to do with how the data is stored in a dictionary and such. We are not going to go to the discussion with that because that's a part of data structure. Okay, so you would study data structures and algorithm. There you shall actually study that later on in future. Apart from that, so I think this is understandable. So only difference is that you cannot have mutable objects that can be modified in place as the keywords, but those can be set as the values, right? I can happily do something like this, right? But I can happily assign an immutable object as the key, say something like that. Then the value could be anything. In fact, the value could be another Python dictionary. Okay, So the value could be anything. The value could be a list. Won't be an issue. All right. So now Z contains a key value pair, but the key is a string and the value is a list. So if I say that list will be returned, and just before you might ask, so let me say, since what it is returning is a list, I can do sub-indexing like this, right? So since this value was a list, I can do some sub-indexing like that. So I extracted the ASDF element. So what was the ASDF element? This was the ASDF element, and the 0th element from that. What was that? So all these kind of things are there. So I believe this is kind of understood, right? All right. So it's been going on for a while. All right. So this is one of the rather important data structures in Python, and we shall be using these data structures quite often. All right. Okay. So one more thing. So with that said, again, if you have any query, and again, we shall see how to actually use these data structures quickly. Then you have tuples. Okay, sometimes people call it tuples. You can call it tuple, anything, same meaning. Huh? Tuples or tuples. Okay, so tuples are enclosed within this kind of brackets, right? Parentheses, something. Right. So this X is a tuple. Right? X is a tuple. So now, of course, I can say X0. That gives me the 0th element of the tuple. Right? But now if I do something like this, I get starting from the 0th element up to and not including the 2nd element. I do all these things. I can do all these things. Right? So tuple is behaving like a list with one exception. Tuples are behaving like a list with one exception. Just see. If I say x0 equal to something like this, it will throw me out, right? So tuples are essentially immutable lists. Tuples are immutable lists. So if you want something like a list, okay, but you want it to be immutable, then tuple is your choice. So after creating a tuple, it behaves like a list, but you cannot modify it. So it's an immutable list. So of course, since tuples are immutable, tuples can be keys in dictionaries. So this cannot be done since this is a list and list was a mutable object. But since I can have the same behavior as a list, but create it as an immutable object, I can convert it to a tuple, but this can be done because that's an immutable object, right? So you get the point. So of course now if I say z colon 1 comma 2 comma 1 comma 2 comma 3 and pass in the tuple, it would show me something, whatever the result is. So this was the key. Okay. So I actually have told you plenty of things today. All right. So if you have any query, someone is asking something back in line. Yes, absolutely. Here we could use double quote. I mean, any rule that we have stated earlier is not violated by something that we are going to teach next. Okay, strings can have all these kind of quotation marks, and that is true even if you are using strings inside a list, inside a dictionary or anywhere, right? As long as it is not violating the rules of being a string, okay, it would be a string no matter where it is. It does not matter where it is, right? So this could be double quotes, it could be triple quotes. All these things are valid. Right. All right. One more data type. It's called a set. And a set is pretty much like mathematical set. So in set theory, you studied set, right? And sets are pretty useful in a very what should I say? In a very mathematical way, if I say so. Say. I had the luck, or rather, I had the opportunity of getting my email ID exposed in many different places, and I get a huge amount of junk emails, right? But sometimes I also get, of course, I get junk emails like someone is willing to pay me $1.5 million absolutely without any reason, right? This kind of emails I get every day. Probably you get as well, right? Sometimes what happens, I get emails that I want to get, but I get those emails multiple times. Sometimes what happens is that people who send bulk emails, they create a mailing list, right? They often do create a mailing list, and where they would have gathered thousands of email IDs where they would send emails, right? Those kind of things. But sometimes what happens, in the same mailing list, maybe my name is appearing, my email ID is appearing thrice. So unfortunately, because of their, what should I say, incompetence, I would get the same email thrice, and they know that. So they would tell you, apologies for sending you the email multiple times, apologies for cross-posting, something like that. But they know what they're doing, but they would still do it, something like that. Oh, thank you if you like it, really. All right. Yeah. This person is one of our ex-students here. Anyway, so if you can take something out of this, it makes me really happy. So set can let you help in this kind of scenarios. Say something like this. Say you have created a mailing list. Okay, let me just create a mailing list, something like that. Okay, and just instead of saying email IDs, let me say email ID, right? Say haha at. So that's one email ID. Maybe that's another email ID. Say that's another email ID. So these are all strings. Email IDs are nothing but strings, right? But somehow, me being unfortunate, say my email ID is appearing here twice. So if somebody is using this mailing list and sending out emails, this person will get the email once, but I would be fortunate enough to get the email twice, unfortunately. Right. So I have a list. This is a Python list. By now you know that, right? By now you know that. Now you would want to maybe, make sure that you don't send the same email to the same person more than once, right? You want to make sure of that. So you want to use a property of sets. When you studied mathematics, you learned a important property of set, that is that every element in a set are unique and well defined, right? So in a set, elements are unique and well defined. So if you convert this list into a set, what would happen? All the duplicate elements will be combined into single elements. So this email ID is duplicate, right? So this email ID is duplicated, but this duplication will be combined into a single element if I convert this list into a set. So if I say y equal to and convert this to a set, just like that. So I'm calling the function set and just passing in the list. And let me just print y. Now what I have essentially is that this element was appearing twice, now it is appearing only once. because by definition of a set, you only have unique well-defined elements, right? So yeah, that uniqueness was violated by having this element appear twice, but now this has been used. So this is one of the, what should I say, this is the most used use case of set function in Python, to remove duplicate elements. So if you have a list, if you have duplicate elements and you want to remove duplicate elements, use set function. And the duplicate elements do not need to be strings. It could be a duplicate list, it could be a duplicate array, it could be a duplicate anything. As long as it's a duplicate copy of something, it will be completely removed and rather combined into a single one. Any duplicated object will be basically combined into a single one. But apart from that, you can do some set mathematics as well. Say, I have a set, something like this. Again, sets are created with this function. If you can say set and write down the elements 1, 2, 3, a, t, g, So this is one way of creating a set. Okay. Also, you can create a set by just putting curly braces. And now curly braces could be what should I say, a confusing syntax, because curly braces are used for dictionaries and sets. So personally, I use curly braces to create dictionaries, and I write set whenever I'm creating a set. But you can use curly braces to create a set, just like this one. So this is also a set. Okay, just keep in mind that the colons do not appear, so it is not a key value pair like a dictionary. So this is a set. So this is one way of declaring a set, and this is another way of declaring a set. Same thing, but I personally prefer writing set so that I am not confused somehow. Okay, people can get confused, right? So I have two sets, A and B. So what happened here? Just hold on a second. Okay, just one more thing. Really sorry. Okay, if you're using this syntax, you just have to put another bracket, right? Just these elements. So if I want to print A, this is A. Okay, if I want to print B, and of course the printing syntax is like what you studied in mathematics, right? In school mathematics you studied this. You have this, right? And if I say A plus B, what do you think would happen? Nothing, right? This is unsupported. Sorry. So now you have some operations, right? I want to do some operations. Say A, and then I'm putting a dot. Now look very carefully. I'm saying A and putting a dot. Now every method, this is called method. These are called methods. Okay. So A is a set object, and if I say A dot, now I have different methods that I can call upon this one. So if I say A dot union and then pass in B, so essentially I have union of set A and B. Yeah, absolutely, A union B, right? So if I say A, then intersection, the A intersection B, then I would have A intersection B. But look very carefully, this intersection is not a function, it's a method that is called on one of the objects, and the other object is passed in as an argument. Something like that. Alright. Sometimes what happens is that I have two lists. Say, try to understand, something like this happens, and regularly this happens. I use Python for my day-to-day tasks. What happens is I have a list of students, right? Plenty of list of huge list of students. Maybe for your placement database, I have a list of students where I have the names of the students, their student ID, their phone number, and their email IDs, right? And then I have another list. Then I have another list, right? Then I have another list, and the list of students in appearing in both the lists are not identical. So there are some students who appear in both of the lists, and there are some students who appear in only one of the lists. I want to combine those two lists. What can I do? Right? What can I do? So I would import them in Python as lists, right? I would import them in Python as lists. Then what would I do? I would convert each one of them into sets. So any duplication would be removed from each one of them. So I convert each one of them into as sets, right? Then I can do something like this: A difference B, right? I can figure out the set differences. So what are the different elements? What are the elements that are there in A but that are not there in B? Similarly, I can do B difference A. That way, or someone is saying, oh no, all the entries won't be same, right? So even if the names of two students are the same, they won't have the same phone number, right? Right? Similarly, I can do B difference A. That will give me the elements that are present in B but not in A, and as such, okay. Or simply all I can do, I can combine everything into a list and then just convert everything into a set, everything to a set. That way, all the duplicate elements will be removed, and I'll be happy, right? Right? Very simple. Talking about methods, I have plenty of different methods that are applicable on many different things, right? So whenever you have a certain object in Python, you can run plenty of different methods on that object, right? Very simple, very quickly. Again, we shall elaborate on these in much greater details. Okay, example methods. All right, say I have a string. Say again, X is a string. Okay, say India. But unfortunately, I forgot to capitalize the name India, right? So X is a string, of course, India, right? So now I can capitalize by calling a method on this. So I'm writing X and putting a dot. Then I can now call a method. I can say capitalize. If I say X dot capitalize, then the first letter of that will be capitalized. So now I have India with I capital, I in uppercase, right? Right? Now if I say X dot upper, everything will be converted to uppercase. All right. If I say X dot lower, everything will be converted to a lowercase. So X dot, so, and if you just hold on for a bit, so there are plenty of operations that you actually do to figure things out, right? Right. All right. So sometimes what happens, I was studying how people write things, right? How people, what should I say, colloquially converse with their friends. So some people use the word LOL, okay, plenty of times. Some people say haha, things like that. Say I'm writing something like, maybe this is how I'm speaking with one of my friends. Say, haha, this is funny, haha, so funny. I am learning Python. So yes, so I have pretty much destroyed the language, right? Right. So now look very carefully. I want to count how many times I have written haha. Someone saying, will this work if X is the list? Of course, if X is the list, then you would have different methods that are pertaining to a list. Okay, so X is a list. If X is a list, and if you write X dot, and then you would encounter methods that are applicable on a list. Okay, so now I want to count how many times I have said haha, right? So of course I can call a method X dot, then I can say count. I can say count and say I can count haha, how many times I have said haha. But it says I have said haha once, but no, I did say haha twice. I was saying haha here once and here once, so it should be twice, right? So I have said haha twice, but it is telling me that I have said haha once. What is the problem? The problem is in the simple fact that this is all in small letters and there was a uppercase here. So this haha, as far as this computer being is concerned, is not identical to this ha, right? So what should I do? I should instead convert this into a lowercase thing. So x dot lower. So now if I just print this, let me just comment it out. If I just print this, now y is a string where everything is in lowercase. Everything is in lowercase, right? Now I can happily count the number of haha. Okay. Sorry, no, I should not count on x. I should count on y, right? I should count on y because y is the all lowercase one. Right. Yeah, I said I destroyed the language. That is why h is not capital in the second one. Maybe I'm talking to a friend, right? There I would probably not worry much about the grammar or anything. Right. So this is not it. There are so much more you can do with this. Okay. So we shall talk about those in our next class. In any case, that will be the end of today's discussion here. We have learned about the built-in data structures that are available with Python, and we shall continue our discussion with how we can actually practically use them. So I would strongly urge you to go through whatever we have discussed today at least once. Okay, go through whatever we have discussed today at least once. Okay, and that'll be nice. All right. So before we coming to the next class, go through whatever we have done today at least once. All right. So with that said, we are going to end our discussion today. I'll be just waiting here for 2 more minutes so that if you have any query, you can just drop the question in. In any case, this will be shared with you. In fact, let me do it right now. Anyone with the link as a viewer, copy link, and this would be your so open this and click save in Google Drive. Otherwise, you won't be able to actually execute this. Let me just show you one more thing. Okay, so this is a link I have given you, right? So if you open this here, you need to have a Google account, right? Oh, of course you have a Google account, right? Okay, it is okay, right? So this is the file I created and gave you. Okay, shared with you. Now by default you won't be able to make changes to this file. So all you have to do is to click on this copy to drive. So this way it will be copied to your own Google Drive. Okay, so that next time you open colab.google.research.google.com, this file will be there, or also in your Google Drive, right? Then you'll be able to make changes and save the changes, right? No, you don't have to write anything so far. Okay, right? All right, just go through this and open this file. I would know how many of you have actually gone through the trouble of opening this file. So please make sure to open this file. Anyway, in any case, thank you for very much for being here patiently for 2 hours 10 minutes. That was a very long time. So thank you very much. If you have any query, feel free to drop me a question, drop me an email, and stay safe. Thank you very much. I'll see you tomorrow.